Hi friends, today we will discuss about force and the relationship between force and motion and the laws of motion. Till now we had been discussing about kinematics. Kinematics is a branch of mechanics which describes how an object moves, what is the path of the object, what is the geometrical shape of that path, whether it is an ellipse or a parabola or a circle. It deals with those kind of questions. It does not ask the fundamental question that why does an object move. Now to answer that question we go into another branch of mechanics called dynamics, and dynamics deals with the fundamental issue of understanding why an object moves. From your everyday experience you must be knowing that there seems to be some sort of relationship between force and motion. We will see what is force and what is the relationship between force and motion. What is a force? A force is a push or pull. It acts on an object. A force requires an agent, that is, there has to be a physical body or physical source of the force. A force is a vector, and a force can be either a contact force or it can be a long range force. By contact force we mean that the object which is applying the force and the object on which the force is being applied, there has to be contact between those two objects. Like for example, in this case you can see this bat is hitting the baseball, so there is contact between these two objects. But there can be long range forces also, like gravitational force. If I drop a ball, it will fall to the ground because of gravitational force, but there is no contact between the ball and the earth's surface initially. So this is a long range force. Similarly, electrical force and magnetic forces, they are also long range forces. Having dealt with what is a force, now we will come to a more fundamental question, that what is the connection between force and motion. Now this is a very important question, and this question has troubled mankind since ages. And the great philosopher Aristotle, based upon his everyday experience, he saw that when a body, suppose this body is moving, suppose this ball is moving, he saw that if this ball is moving, then ultimately, suppose it was moving with velocity v, then he saw that ultimately it comes to rest, that is v becomes 0. So Aristotle thought that in order to keep this body in motion, you require an external agency, you require an external thing, and he gave the name of that thing force. So Aristotle propounded the theory that to keep any body in motion, you require an external agency, external thing called force. So if you don't apply force, ultimately every body from a state of motion will come to state of rest. Okay, so this was the theory of Aristotle. Based upon this theory, Aristotle also propounded that since each and every body tries to come into this position of rest, so he called that this position of rest is some sort of preferred position of each and every body of the universe. He called it like the natural state of a body. So you keep a body in motion or anywhere, ultimately it will come to rest, and this rest position is the preferred or natural position of an object. This theory is very much in tune with our common everyday experience. You throw a ball, ultimately it will come to stop. This theory was widely accepted till 1600, until the time the great man Galileo came into picture. Why did no one till this time could think about that there is some lacunae in this theory? Now, having studied physics, and after studying physics for say 300 and 400 years since the time of Galileo, we know that this theory, Aristotle's theory, is wrong. And why does an object which is moving come to rest? Because there are some external forces like friction or drag force or viscosity, any such force acting on the body. So this theory is ultimately wrong. But just to say a theory that okay, it is wrong is one thing, but to prove it experimentally and to give a valid theoretical argument for it, it's an entirely different thing. This was the whole debate which was going on in 16th and 17th century, that whether Aristotle picture was correct or the new picture being shown by Galileo, whether that is correct. And now how did Galileo prove? Now Galileo gave a theory that you don't require any external force to keep a body in motion. That if your body is moving, then that body has got an inherent property that it will keep on moving on its own without any external force, without any external agency. How did Galileo prove this thing? He proved it like this. Suppose a ball is released from this height. This surface is completely frictionless. So when a ball is released from this height, ultimately it will reach the same height. Why it will reach the same height? Because of conservation of energy. So what then Galileo did? Made this surface somewhat less steep. Okay, so when this surface or this curve was made less steep, in order to reach the same height, the ball had to cover a greater distance this side. Why it will have to cover a greater distance? Because now this curve is less steep. So Galileo propounded that if I make this curve or this surface or this track or path completely horizontal, then this ball will keep on moving, because in order to reach this height it will have to cover infinite distance. Ultimately it will not reach that height, but it will keep on moving. So this was the experiment done by Galileo to prove that if a ball is in motion, it will continue to be in motion. So Galileo said that there is nothing like preferred state of rest. Like what Aristotle said, that there is a preferred state of rest. Everything like this ball likes to come to a position of rest. Galileo said that there is no such preferred state. Each body will be in position of rest or in position of motion with velocity v, and it will continue to be with uniform velocity if no external force is acting upon it. So this law of inertia of Galileo was further developed by Newton, and he came up with this Newton's formula, which says that an object at rest stays at rest unless acted on by an external force. The first part of this Newton's law is very simple. Suppose you have kept an object here, it is at rest, velocity is equal to 0, you don't apply any force, it will remain at rest. So this is no-brainer. The difficult or the tricky part or the counterintuitive part comes in the second part, which says that an object in motion continues to travel with constant speed in a straight line, that is with constant velocity, unless acted on by an external force. There is a common misconception that force is the cause of motion. Okay, but no, force is not the cause of the motion, rather force is the cause of change in motion. So remember, don't interpret force as the cause of motion. For motion you don't require force. If a body is moving with constant velocity v, say 10 km per hour, you don't require a force for it. But suppose a body is at rest, v is equal to 0. Now from rest you want this body to have say velocity 10 meter per second. There is change of motion. For this you require force. So the myth is that force is required for motion. No, it's wrong. Force is not required for motion. The reality is that force is required for changes in motion